right, in this example, we are going to be finding the explicit formula for these geometric sequences. Sorry, I'm going to keep making that mistake. For these geometric sequences, and then we're going to find the term that they ask for. So we're going to find the explicit formula first, and then we're going to find the term that they ask for. So if we remember from a couple slides earlier, I should say a couple videos earlier, the explicit formula looks like this. Where A is the first term and R is the common ratio. So the first thing we need to figure out is what the common ratio is. Because the first term is easy, it's just the first term. But we have to figure out what the common ratio is going to be. So what do I need to multiply each one of these by to get to the next one? Well, in this case, it would be -3, right? -3 times -3 is +9. +9 times -3 is -27. We're assuming that these are geometric. We're told that. So we don't actually have to check all of them, but they all should and do work. So let's go ahead and write our explicit formula. So we have A sub n equals -3 is our first term times R is also -3, right? That's what we said we were multiplying by each time. So R is also -3 to the n minus 1. Now, normally, this is as simplified as it gets. We can't usually simplify these like we did with the arithmetic sequences. However, when the first term and the multiplier match, we can simplify. So I'm going to show that. So this only happens when the multiplier and the first term are the same. So hopefully we remember that we could split this up into these two, right? I could say that this is n plus -1, right? So I can split this into two separate bases, and to combine these, I would add the exponents. So I'm just doing the opposite of that, so I can split these up. So now I can add this exponent with this exponent, which is an invisible 1, right? So I have 1 and -1. So these two actually cancel out because 1 minus 1 is 0, right? And anything to the 0 power is just 1. So these cancel each other out, and I end up with A sub n equals -3 to the n power. Now remember, this only works if this number and this number match. And you're not required to do this simplification even if you run into that situation. I just wanted to show you that it does in fact work. And I can simplify down to just -3 to the n if these two things match. Is the only time I can simplify though. So now let's go ahead and find A sub 9. So we're going to find A sub 9, and so that's going to be -3 to the 9, right? Because the way that we simplified it, we just use this n becomes this n, right? That works for the way that we simplified it. So we would plug that into a calculator, -3 to the 9, and we would get -19683. So this is our 9th term for number 5. All right, so hopefully that makes sense and not too much trouble. Let's do number 6. So for number 6, the first thing we need to ask ourselves is, what are we multiplying each one by to get to the next one? In this case, it's +3, right? -1 times +3 is -3. So again, here, the sign alternated each time, so our multiplier was negative. Here, the sign stays the same. It's negative, but it's always the same, so our multiplier is going to be positive. So if the sign doesn't change, then the multiplier is positive. So the multiplier is going to be positive 3. So I'm going to write that r equals 3 in this case. So my formula would be an equals the first term, which is negative 1, 3 to the n minus 1. So the only thing we could do to simplify this would be to just simply not write the 1, right? Because we don't actually need it. So I could write this as negative 3n minus 1. I don't need that 1. And once the 1 is gone, I don't really need the parentheses either because they only apply to the 3. The n minus 1 only applies to the 3. So without the parentheses, it still only applies to the 3. So I can go ahead and drop those as well. But that's the only simplifying that we can do here. So remember, though, when you're putting this into your calculator, that now the n minus 1 does not apply to the negative. So if you're putting this in your calculator, you would not put parentheses around the negative because it doesn't apply to the negative. So let's find A10, or the 10th term. So A10 equals negative 3 to the 10 minus 1, or negative 3 to the 9th. So it's always going to be 1 less than this number, right? Well, this looks very familiar. We had negative 3 to the 9th over here, and here we have negative 3 to the 9th. The only difference is that the exponent doesn't apply to the negative. But since the exponent is odd, that's not actually going to change anything. So it turns out that these answers are exactly the same. That's just happenstance. There's no reason why these should be the same. It just happened that it worked out that way, because notice the term number we're finding is not even the same. So it just worked out that way. There we go. So that is finding explicit formulas for geometric sequences. And we're going to do a couple more examples of this in the next video. So I will see you there.